we take a look at one example how to use this general stability criteria to determine stability. Now we're given a closed loop process. The process transfer function is given by 1 over 5s plus 1 times twice s plus 1. So it is second order process without any delay term with two poles. And then if you implement a proportional controller with GC equals -5, which is whether the closed loop system will be stable or not. Now for this case, we find out the closed loop transfer function first. So if I write it ys over rs, we know that we simply becomes gp gc 1 plus gp gc. So we plug in these values, we'll end up getting 5s plus 1 twice s plus 1 times -5 over 1 plus 1 over 5s plus 1 2s plus 1 -5. Okay. If we simplify the model, we'll have the both cases. This will be this, and then this will be in the denominator for both this numerator and denominator. So we'll end up getting something like -5 over 5s plus 1 twice s plus 1 minus 5. So if we further simplify this, we'll end up getting 10s squared, so that 5s 2s 10s squared, and we'll have 7s plus 1 minus 5, so minus 4. So this is the closed loop transfer function. Now to find out what are the poles of this transfer function. Now we know that the poles are nothing but the solution of the denominator polynomial, so that if you set the denominator polynomial to 0, we get this equation, and the solution of this equation will give us the poles. Just to remind that this is also known as what is called this characteristics equation. Okay. Because this equation determines the characteristic of the response of the process. So if I look at this, it will be, the poles will be the minus b plus minus b square minus 4ac twice a for a second order polynomial equation as square plus bs plus c equals 0. So we'll have -7 plus minus 7 squared, so 49 minus 4ac, so 4, 10, and c, so this will give us 160 over 2 times 10. Okay. So this, you see that this term, it's 49 plus something. So this term entirely will be greater than 7 anyway. This is the -7 plus minus something greater than 7. So you see that when the term is negative, we get a negative pole. When the term is positive, we get a positive pole. So we'll have one negative pole, one positive pole. So without determining the numerical value, we see that the closed loop process will be unstable. The question asks us, will the closed loop system be stable? We see that the one pole is positive, another is negative. So the closed loop process will not be stable. So it will be unstable.